You know, some of the wildest discoveries are total accidents. Today, we're going to unpack a story that kicks off with a web developer just trying to make something look cool and ends with a brand new, powerful security vulnerability that literally changes how we should think about the pixels on our screens.
So where did this all start? Well, believe it or not, the story doesn't begin with a hacker trying to break things. Nope, it started with a developer just messing around, trying to keep up with the latest design trends. And that simple curiosity, well, it accidentally opened the door to a whole new way to attack websites.
Okay, so picture this. Apple comes out with its super slick liquid glass design. A developer sees it, thinks, hey, I wonder if I can build that, and gets to work. And they do it. They manage to recreate the effect perfectly using totally standard web stuff, CSS and these things called SVG filters.
And then came the million-dollar question. An iframe, if you don't know, is basically just a window that lets you stick one website inside of another one. So the developer wondered, could my little visual effect be layered on top of a totally separate website? I mean, no way that would work, right? Well, guess what? The answer was a huge yes. And this is the core of the whole discovery. These visual filters, which were only ever meant to make things look pretty, could actually be applied to a website from a completely different place. And, what's more, they could interact with it. This realization basically opened up Pandora's box of possibilities.
So what this developer had just stumbled onto completely by accident was this massive upgrade to a classic web attack called clickjacking. So just to make sure we're on the same page, classic clickjacking is pretty simple. It's like putting an invisible like button from, say, Facebook right on top of a play video button. You think you're about to watch a cat video, but bam, you've just liked some random page. It works for a single click, sure, but anything more complicated than that, it's just not practical.
But this SVG clickjacking, it is on a whole other level. We are not talking about a simple dumb trick anymore. This new method transforms the attack into something complex, something interactive. It can actually react to what you're doing and guide you step by step through a much bigger trap. Okay, so the big question is, how does this even work? How do you program an attack with pixels? It sounds like science fiction. Well, it all comes down to using these SVG filters to literally read the color of pixels and then turn that visual information into commands. It all boils down to this really clever four-step process. First, the filter zeroes in on a tiny little patch of the hidden website. Then, it reads the color of those pixels. Step 3, it turns that color into a simple binary signal, like on or off. And finally, that signal becomes a trigger for the next stage of the attack, like making a new fake button appear. And this is where it gets mind-blowing. By treating different colors as on or off, and then combining those signals from different pixels, an attacker can build fundamental logic gates. Not and or. I mean, that's literally the foundation of every computer we use today.
Yeah, this quote says it all, doesn't it? An SVG filter stops being just a simple visual tool. It effectively becomes a tiny, programmable computer that can run a whole script based on nothing more than the visual changes happening on the hidden website below it. Wow.
And listen, this isn't just some fun thought experiment. This is real. This technique has been used to create actual working attacks against some of the biggest names on the internet. In fact, the researcher who found this, they pulled off a super complex multi-stage attack against Google Docs. It was so slick, so effective, that Google paid them a bug bounty for it. A pretty specific number, by the way. A little nod to old-school hacker slang.
And just look at the flow of this attack. It's not just one click, it's a whole conversation. The filter is actually smart enough to see when a pop-up appears. It can watch for pixel color changes to know when you're typing, and then it guides you from one fake step to the next. That kind of responsive, intelligent attack is what makes it so much more dangerous.
But wait, it gets even wilder. This technique also solves another classic problem for hackers. How do you steal information, like, say, a secret code on the screen, if you can't get the user to actually click a button that sends it to you? The solution is just genius. The SVG filter can read the sensitive data pixel by pixel from the hidden page. Then, it encodes all that data into a web link. And then, get this, it generates a QR code right there on the screen. The user gets a pop-up saying something like, "Scan here to continue," and they think it's harmless. But by scanning it, they use their own phone to send all that stolen data straight to the attacker.
So, what's the big picture here? What does all this mean for us? Well, this isn't just about one new bug. This discovery fundamentally changes how we have to think about web security. Stuff that we always thought of as just harmless window dressing, well, it can now be turned into a weapon.
All right, let's break down the big takeaways. First, simple visual effects can become full-blown programmable attack tools. Second, this means clickjacking isn't just for single clicks anymore. These new attacks can be interactive and incredibly convincing. And maybe the scariest part, data can be stolen just by looking at it, totally blurring the line between what a website looks like and what it can actually do.
Which really leaves us with this one big, kind of scary question. If the very pixels on our screen can be programmed with complex logic specifically to trick us, what does seeing is believing even mean online anymore? It forces us to realize that what we see on the web might not be so simple after all.